everyone. This side Dr. Amit Kumar Pandey. I am going to discuss the new topic, multiprocessor scheduling in operating system. So let's see one by one what is inside. Okay, here you can see definition of multiprocessor system. So a multiprocessor system is a computer system that consists of multiple processors working together to execute programs, multiple programs. Characteristics of multiprocessor operating system are parallelism, increased throughput, scalability. Means multiple tasks can be executed simultaneously. Tasks can be completed faster due to parallel processing, and additional processors can be added to the system for enhancing the performance. Now, let's see in depth about multiprocessor operating system and multiprocessor scheduling. In multiprocessor scheduling, we efficiently utilize the resources. Means here is proper scheduling which ensures that all processors are effectively utilized and maximizing the system performance. Then load balancing, distributing tasks evenly among the processors prevent overloading and improve system responsiveness. Responsiveness is determined by how quickly the tasks are executed by the processor. Load imbalance, synchronization, scalability. If we are doing such type of things, then there can be problem with it. You know? So load imbalance, non-uniform distribution of tasks can lead to some processors being underutilized while others are overloaded. Second one is synchronization. Coordinating access to shared resources among multiple processors requires efficient synchronization mechanism. Third one is scalability. Scheduling algorithm must scale efficiently as the number of processors are increased. Now, see about SMP. SMP means symmetric multiprocessor architecture. SMP is a multiprocessor architecture where all processors have equal access to system resources and memory. All processor access memory with the similar latency, and the task can be evenly distributed among processors for optimal performance, and additional processors can be added without significant architectural changes. This is SMP. Means all the tasks, all the load are equally distributed among all the processors which are present inside the system. Here you can see the diagram for SMP, this symmetric multiprocessor architecture. Here you can see here is a memory, and memory is shared by both CPU 0 and CPU 1. Here is local cache memory for CPU 0, and here is local cache memory for CPU 1 and register. Okay. This is SMP. Now, what is inside SMP? Schedulers can assign tasks to any available processor based on load balancing algorithm. Means if there is any new task, it should be given to the processor which have less load, so that there will be equal load on all the processors. Now, shared memory, all processors have equal access to shared memory, facilitating data sharing among tasks. For example, Linux clear scheduler. Now, what is AMP? Asymmetric multiprocessor. AMP is a multiprocessor architecture where processors are designed for specific tasks and may have different capabilities. In AMP, asymmetric multiprocessor, there can be multiple processors with different capability, and there is a processor which acts like as a master and other as a slaves. So master control all the slaves and distribute all the work among the processors. Characteristics: heterogeneous processing element. Processors may vary in terms of performance, power consumption, or specialized functionality. In AMP, asymmetric multiple processing, processor may have different access latency to the memory, and different processor handle a specific type of task based on their capability. Here you can see the diagram for asymmetric multiprocessing. As you can see, here are three processors. Here are three processors P1, P2, P3, and one processor P2 is acting like a master, and others are acting as slave. Now, difference between symmetric and asymmetric multiprocessing. Here is a diagram for symmetric multiprocessing. Here you can see there are processor 1, processor 2, processor 3, all are shared the memory, and the load is distributed among all those processors. CPU 1, CPU 2, CPU 3. Okay. But in asymmetric multiprocessing, you can see here are three processors in which one is acting like a master and other are acting like a slave. And no memory is shared in asymmetric multiprocessing. So what is the difference? But load is distributed with balance. Load is distributed according to the capability of particular processor. In symmetric, memory is shareable, and asymmetric memory is not shared among all the processors. Here the same, which I told you. In SMP, all processors are treated equally, easy to scale by adding identical processors, and lower management overhead due to uniformity. But in asymmetric multiprocessing, processors are optimized for a specific task, can achieve higher efficiency for a specific workload, and higher management overhead due to heterogeneity, because here are different type of processors we include inside the system. Here are some references which I have used in my PPT. Thank you all. Thank you for being with me in this lecture.